In this video, we're going to be talking about Module 1, Section 1 of Algebra 2, solving linear equations. So kind of to get us started for the year, we're going to talk about what it means to solve a linear equation, something I know we all have done plenty of times before, and some properties that are involved in solving slightly more complex equations. So first, just in general, what does it mean to solve a linear equation? Well, the definition we're going to have is to solve a linear equation, we're finding a value for an unknown variable that makes the equation true. And a property we can use to do that, to solve these linear equations, is called the addition property of equality. And the addition property of equality is something you've probably used hundreds of times already. Essentially what it is that an equation is still equal when adding or subtracting the same value to both sides. So essentially, I can add a 4 to the left side of an equation and a 4 to the right side of an equation, and that equation is still balanced. It's still true. It's still equal. Or I can subtract x from both sides of an equation, and it's still equal. Applying that to some examples, if we look at this first one, x minus 3 equals 11, we need to isolate this x value. Get this x value by itself. Well, there's one step to do that. We need to get rid of the minus 3, that negative 3. Let's use the addition property to do that. If I add 3 to both sides, it's still a true equation. The negative 3 and plus 3 cancel out. The 11 plus 3 gives me 14. So I have x equals 14. And again, I can always check that. I can plug 14 into the original equation. Is 14 minus 3 11? Yes, it is. So we know this is the correct answer. Looking at the next example, very similar. X plus 3 is 11. I'm going to do a minus 3 to both sides. So subtracting those 3's, x equals 8. Well, let's check. Does 8 plus 3 give me 11? It does. So that's addition and subtraction. Also, whoops, I made an extra mark there. We can do this with multiplication and division. So very similarly, the multiplication property of equality is when an equation is still equal when multiplying or dividing the same value from both sides. Oops, looks like I shifted over here. So looking at the first example, using the multiplication property, 4x equals 20. Again, working on isolating that x value right in there. Well, it's being multiplied by a 4. So let's divide 4 from the left and from the right. Because when I divide 4, 4 divided by 4 is 1. 20 divided by 4 gives me 5. So I'm just left with x is 5. I can always double check by plugging it back in. 4 times 5 does give me 20. Looking at this example on the right, if I'm isolating y, there's a negative out in front. A really common strategy to get rid of this negative would just be either multiply or divide, I'll divide both sides, by a negative 1. And why negative 1? Well, we know that negative divided by a negative gives me a positive y. 14 divided by negative 1 is negative 14, and you got your solution. The last one down here, set up like a proportion. One common strategy is cross multiplication, and that's perfectly fine. But using this multiplication property, very similarly, I'm just going to go ahead and multiply both sides by 4. Since k is divided by 4, I'm choosing to multiply, because 4 divided by 4 just gives me 1. So I have k left. Now I'm multiplying this fraction. Well, with our fraction rules, we multiply across the numerator and the denominator, which we can just say the denominator is 1, because 4 over 1 is just 4. So 4 times 4, 16. 7 times 1 is 7. So k is 16/7. Now let's look at some examples that have a combination of that addition property and multiplication property. For this first example, again working on isolating x. Well, when possible, we want to get rid of addition and subtraction first. In other words, this plus 6 tells us we need to subtract 6 from both sides. We're left with 3x on the left, and that's equal to 6 on the right. From here, 3 times x tells us we can divide by 3. That gives us x. 6 divided by 3 equals 2. The next example, we have a distributive property involved, so we want to make sure to multiply this 4 out first. This 4 needs to be distributed to the x and the negative 2. So we have 4x, and then 4 times the negative 2 is minus 8, equals 6x minus 10. Now we've got x's on both sides. Whenever you see variables on both sides, strategy is going to be let's get the variable to one side. So I'm going to take this 4x, since it's positive, and I'm going to subtract 4x from both sides. When I do that, the 4x minus 4x cancels, and I'm left with negative 8 on the left. 6x minus 4x is 2x. I'm going to bring this up here and continue. From here, since x is on the right side and it's by itself over there on the right side, we're going to add 10 next. 2 equals 2x. Here we can finally divide 2, and you get x to be 1. Another common type of equation that you might see here is equations involving some fractions, which shouldn't be much of a worry for us as long as we're solid in our rules with fractions. If we define how to what's called clear a fraction with the LCD, hopefully we remember that the LCD stands for the least common denominator. In other words, what's the common value that we can multiply to in the bottom of the fraction, the denominator? So what we need to do is we need to find the LCD and multiply everything in the equation, multiply that equation by the least common denominator. And that's going to clear those fractions out right away. Rather than working with them the whole time, we'll get them out of the way. So looking at this first example, we have in our denominator a 3, a 4, and a 4. The least common denominator that these three numbers would be able to multiply to, I'm going to write that off to the side, is going to be 12. So what I'm going to do now is I'm going to take every value here and multiply it by 12. So what I get when I do that is 4/3 x times 12. Well, I'm just going to multiply the 12 to the 4. You can just multiply the numbers on the top. So I get 48 thirds x, 12 and negative 7 gives me minus 84 fourths, and then 5, or negative 5 fourths and 12 would be negative 60 fourths. Because we multiplied all this by the LCD, we know that each one of these fractions will simplify to just an integer. So for example, 48 thirds, well 48 divided by 3 is just 16. So we'll write that a lot easier as 16x. And then negative 84 fourths, well 84 divided by 4 is 21, so negative 21. Negative 60 divided by 4, negative 15. Now we're dealing with something a little more basic, and we can use our addition property, where I can add 12 to or 21 to both sides, and then our division property from there. So let me go down just a bit. We've got 16x, these cancel, equals 6. From there, divide both sides by 16. We get 16 sixteenths. But we also know that can simplify a little bit. If I take a 2 out of the top and the bottom, I would get 3/8. So I always want to write my fractions in the simplest form, 3/8. The next example, we have some values with fractions and some without. Well, again, we want to do, if we have any values with fractions in here, normally we want to use this clearing fractions with LCD method. But we really only have to worry about these two values. So what's the LCD between 4 and 2? Well, the least common denominator there is going to be 4. If I multiply everything by 4, again, you only need to multiply in the numerator when we multiply with fractions. So we'd have 4 times 3n plus 5 times that whole quantity over 2 equals 4 times 4 is 16 plus 4 times the quantity 4n plus 2, and that's over 4 as well. If we can simplify right away with the fractions, go ahead and do that. When I say that, I mean, can I simplify 4 on the top over 2 on the bottom? Yeah. I could take a 2 out of both of those, and that just gives me 2 and 1. Or can I simplify this 4 divided by this 4? Yeah, it just gives me 1 and 1. Well, As you know, I don't really need to write 1 in the bottom of a fraction, so I'm just going to write what I have left. 2 times 3n plus 5 equals 16 plus 4n plus 2. From here, I see a distributive property. I'm going to multiply the 2 to both terms. 6n plus 10. And then on the right side, I can actually combine a couple like terms. 16 and 2 gives me 18 plus 4n. We have that same situation as before with n's on both sides, so let me subtract 4n. Those cancel. You're left with 2n plus 10 equals 18. Almost there now. Subtract the 10 from both sides. 2n equals 8. And then finally, I can divide this by 2 and divide this by 2. N equals 4. And finally, we just want to take a look at what are some special situations or special solutions when solving equations. And really, you're going to run into two things. You're going to run into a situation where an equation has no answer, or an equation that has an infinite number of answers, all real numbers. Any number you want to plug in there will work to satisfy that equation. And to look for these no solutions and all real numbers, special types of solutions, we either need to look for what's called a contradiction or an identity. So starting with a contradiction is when an equation states that two unequal values are actually equal. For example, a contradiction would be 3 equals 4. So you're solving an equation and all of a sudden you end up with 3 on the left side and 4 on the right side. You know, that's a contradiction. What does that tell us? This is the important part. This means no solution. If you run into a contradiction, it means there is no solution to that equation. Next is an identity. An identity is when an equation states that two equal values are actually equal. Now that seems pretty redundant, but that's the point. If you are solving an equation and all of a sudden you get the value 1 equals 1, well, yeah, 1 equals 1. What that tells you, since you got an identity value, is that the solution is all real numbers. All real numbers. So let's take a look at what that might look like here, solving this first example. So first off, before we can do much, we've got some distribution to take care of. I see some distribution here with a negative. You can also think of that as -1 to distribute and a -3 to distribute. So let's do both of those in this step. -1 times 7y is -7y. -1 times 2, -2. -3 times 4y is -12y. -3 times -5, +15. From here, if we can combine like terms, let's do it. So I have 4 minus 7, -3y's. I have 9y's minus 12y's, -3y's. We need to get the y's on the same side. I'm going to go ahead and add this 3y to the left and add it to the right. You can probably already see an issue coming because this cancels and this cancels. So we get a contradiction. Looking back on our definitions, a contradiction means what? No solution to this equation. There's no value you can plug in for y up here and up here that would make the left side equal the right side. Looking at the very last example, I'm going to go ahead and distribute this 4 and this negative 1. Whoops, was it ugly too? Combining like terms I can, I see a 6x minus 2x gives me 4x's. I see a 5 and a positive 3 plus 8. So now I can already see I have the left side equal to the right side. So you can probably from here say, well, this is going to be an identity solution. But if I continue this on using our patterns we've been doing with addition, multiplication properties, subtract 4x from both sides, you're left with 8 equals 8. Obviously, this is now an identity where 8 always equals 8. So this is an answer with all real solutions. In other words, no matter what number I plug in for x here and here and here, almost missed that one, the left side is always going to equal the right side. Well, that's it for Module 1, Section 1. Make sure you complete the assignment on Classroom and show all your work, write down all your solutions on the last page of these notes. You'll see a heading that says Module 1, Section 1 Assignment. That's where you can put all your work and your scratch work and write down your solution.